Okay, now we have one of the problems where a particle moves along a coordinate line in the velocity. So originally when we were doing this, we were finding the first derivative, which is the velocity, first derivative of the position function, right? Here's the position function. The first derivative is the velocity function, and then speed is the absolute value of whatever the velocity is, and then acceleration is the second derivative. Well, now we're working backwards. We're starting with the velocity function, and we have to find the position function, which means we integrate. So the position function is equal to the integral of the velocity function. And we are just trying to find, when s of 0 is equal to 0, right? So we're starting here. All right, so the position function is, so when we integrate negative 3x squared, we end up with negative 3, 2 plus 1 is 3, divide 3, so we end up with negative x cubed, and the derivative of, these should have been t's, I'm sorry. We're going to add a 1, so divide by 2, 8 divided 2 is 4t squared, and then the integral of 60 is, think about that as t to the 0 plus 1, divide 1, so that is 60t. And then it says, find the position function when s is equal to 0. Oh, and then there's this constant over here that's 0. S of 0 is equal to 0. There you go. So you work backwards to find the position function. Okay, now we have the acceleration and we need to find the position function. That means that we're going to have to integrate twice, because the velocity function is what you get when you, the velocity function is what you get when you take the integral of the acceleration function. If I didn't have dt over here, oh, that's losing a lot of points. That is not good. You have to have this to accompany this right here. All right, so velocity function is, so we add a 1, so 12t squared, we add a 1, that means divide 3, that's 4t cubed, and then 60t to the first, we add 1, divide 2, we get subtract 30t squared. Okay, and then plus 0. But we need to find the position function. So now we integrate well, you know, I should have in here integrated that, and then that would have been a plus c, I don't know. Anyway, so now when we integrate this, we're going to add 1, which will be a 4, divide 4, leaves us with t to the 4th, minus, we're going to add 1, divide by 3, 10t cubed, and but that would be the position function. Just like that. All right. Where, let's see. Yeah. And this one, you're just going to, I'm not going to do this with you, but this is the one where you just integrate once, because you're going to find the velocity function. All right, that is it for this one.